Good morning, everyone, and thank you for coming to this session. I know there are a lot of many different interesting sessions running at the same time, and I appreciate you came to this one. My name is Mahmoud. I work for VMware on Spring Batch. I joined VMware Pivotal 7 years ago, and since then I worked on Spring Batch. I also work on other projects from the Spring portfolio, but mainly on Spring Batch. And today I'm going to talk to you about batch processing. So everyone is talking about AI and interesting stuff. And yeah, I have to give you a presentation about maybe the most boring subject of the conference, batch processing. How can I make this interesting? I don't know. I even asked ChatGPT to give me a joke about it, and it failed. Yeah, it's something, I don't know if it's still a thing in 2025. Anyway, this presentation is about, I want to give you an update on the status of the project and present the new features of the latest version, Spring Batch 5.2, and then show you some of the features that are coming in the next major version, which is planned for later this year. And by the end of the presentation, I will explain the support policies and timelines so you have an idea about the support periods. Okay, so a quick introduction about the state of things for Spring Batch in the last year. Spring Batch is still a very active project. It's one of the top projects of the Spring portfolio according to the State of Spring of last year. So it's one of the top 5, I guess. So people are still using Spring Batch. Batch processing is still a thing, and this is good for the project. I also wanted to show you some stats about which version is used according to the Maven downloads from Maven Central. And one interesting thing is that Spring Batch 2.1 and 2.2 are still used, which were released like 10 years ago. And this means that batch workloads are, once they are working fine, nobody wants to update them or to upgrade them, and they are like there for decades. So yeah, batch processing is still here, and yeah. However, I don't recommend to stay on these versions, and I recommend people to migrate as soon as possible to the latest and greatest versions. For the moment, it's 5.2, and I try to also show you the trend of which version is used currently, and we see that, for example, Spring Batch 5.1 was rising, and the last one, 5.2, which was released last November, is now starting to be used. The good thing is also that people are not using the versions like 5.0 and 4.2 and so on. This is decreasing, which is a good sign that people are moving to the latest versions. Okay, so speaking about the latest version, 5.2, so this is one of the biggest minor releases we have ever released. It's packed with a lot of features, and I try to select the most impactful features in this release. So the first one is the addition of MongoDB as a job repository. So now you can use MongoDB as a job repository. And this is like the first NoSQL job repository implementation. We took some time to try to create a new persistence model suitable for NoSQL stores, meaning that this is the first implementation based on this persistent model, but we are looking to add others. The persistence model is like agnostic from any implementation, so we can like implement the same idea with other stores. The implementation is based on Spring Data MongoDB, and it's faster than relational job repository implementations. The reason is that the theoretical reason, I will show you a benchmark for that. But the theoretical reason is that the new persistence model is denormalized, meaning that we don't have like joins between tables, since it's a document-oriented model. Like for example, we embed the execution context of a step inside the same document, so we don't have to join between two tables or something like that. So we designed the model in a way that we avoid joins between tables, which is very expensive, and that's what makes the implementation faster than the relational implementations. And I have a quick benchmark here between a PostgreSQL job repository and a MongoDB job repository. So the idea here is that I have the same job. It's a simple job with 2 steps. Step 1 is a simple tasklet, and step 2 is like a chunk-oriented tasklet with like 100,000 items, I think. So for the same job, we will have a lot of interactions with the job repository to persist metadata and load metadata and so on. And we see the total execution time of the job. And with a Postgres repository, it takes 41 seconds. This is an average value of several executions, while with the MongoDB implementation, it takes only 19. So it's 2 times faster, basically, for the same batch workload. And this is interesting because if you have the option to choose between MongoDB and Postgres as a job repository, you should use that MongoDB, so you will have like a faster execution of the overall job. Yes, sure.
In seconds, these are database calls. Even if you're doing join, assuming there's no full table scan or anything, why should it take that kind of?
Yeah, because I have like a huge data set on purpose with a small chunk size. Like I have 100,000 items with like a chunk size of 10 or 100. So I have 10,000 transactions, and these transactions like there are.
This is for 10,000.
Yes, so this is for the 100,000 items. So the job in itself, I mean, the business logic takes like a couple seconds because it doesn't interact with the database on purpose, so that I can isolate all the database transaction and interactions for the metadata, not for the business data. So I can show you. Maybe it's a good thing to do. I think it's this one. Yeah, so this is the job. 2 steps, step 1 and step 2. The first step is like a simple tasklet, and the second step is like a chunk-oriented one with a reader, processor, writer. The reader is reading data from a persons.csv file with 100,000 items. The processor just like uppercases the first name and last name of the person, and the writer writes it in another file. So this, I mean, the business logic itself takes maybe less than a second, but the interactions with the database, like for storing metadata and loading it, is the important part we are benchmarking here. And in the benchmark, I have like MongoDB, Postgres, and I will show you another one. But yeah, it's the same job used in these 3 benchmarks. Okay.
That's okay. It didn't say. I thought one job was one invocation is taking that.
Yeah. So this is the total job execution time in seconds. Okay. Good question, by the way. So you see, all these seconds are for the interaction with the job repository, basically, and yeah, we see that there is a huge improvement for me. 2 times faster is already huge. So another feature we added is the resourceless job repository implementation. So this time it's like a no-op implementation of the job repository interface. So there are no batch metadata at all, no database, nothing. Everything is in memory, and actually there is nothing. So we don't store anything and we don't load anything. And obviously this is like for, not for every job. So sometimes you want your job to be restartable. So if it fails in the middle, you want the metadata to be stored so you can restart it from where it left off. But of course, if you don't store anything, you cannot have that. So it's suitable for idempotent jobs so that you can run multiple times and they don't have any side effects. So they have the same effect every time. It's also suitable for transactional and non-transactional steps. So even if you don't have a job repository at all, I mean, it's a resourceless one, you can still have transactional behavior. And if you don't want that, you can use a special transaction manager called resourceless transaction manager. It's also a no-op implementation of the Spring Framework interface platform transaction manager. However, this is not suitable for every use case where the execution context is involved, meaning like, for example, if you want to share data between two steps, you can use the execution context. So step one will put data in the execution context and step two will load it from there. So if there is an involvement of the execution context, this job repository is not the one to choose, simply because there is no storage for this execution context. There is no place to write to and to read from. Another case maybe here, which is interesting to share, is when you use a partition step. So sometimes you partition the data set, we create several partitions, and we want like worker steps to work on each partition. The partition metadata is passed through the execution context, and this is also a use case where you cannot use the resources job repository. So yeah, there are some cases that are not covered, but for the cases that are covered, it will be very fast. It's not thread safe on purpose. Again, it's not suitable for a concurrent environment. And of course, it's way faster than any other implementation of job repository simply because it doesn't have any interaction with any disk or something. And I have the same benchmark, and here I think the overall job took like less than a second, which is 2 orders of magnitude faster than any other job repository implementation. This is very interesting because if you have like, those are seconds, but if you have a job that takes 3 to 4 hours and you can like take it down to a few minutes, it can be really a game changer. It's a huge improvement. Okay, so this is the resourceless job repository, another great feature I think in 5.2. Another feature is the composite item reader. This is also similar to, if you are familiar with Spring Batch, like we have a composite item writer, composite item processor, and so on. So those are like composite artifacts that delegate to several other writers or processors. It's a chain of calls. And we introduce another implementation for readers. And it's useful when you have like different sources with the same target format. Like for example, you have a flat file. I think I have an example here. A flat file containing persons, data, and a database table containing the same data. You can use this kind of composite reader to read data from both sources and write it somewhere. And the idea here is that you don't have to, because you don't have to write 2 steps, because without this composite reader, how would you do that? So you would have to write a step for this file, a step for this table here, maybe run them in parallel or something like that. So the configuration of the job is like a bit cumbersome, especially if you have a lot of data sources. Like imagine you have a third data source, an XML file or something. So with this composite reader, you just need to define your readers and compose them and use them in the step. So you would have a single step instead of 3 or 4 steps. Maybe I think I have an example as well here for. Yeah, it's this one. So imagine I have a person record. So this is the target type. And I can, like I have two files, person with ID and name, person 1, persons 2, same thing, and a database, okay? So person source. This is the table where I have some person data. So I can define 3 readers and a composite item reader with these 3 delegates. And now I can read the data from these 2 files and then the database and write them where it should be. So for example here, I think the writer is in a table called person target. So I can run this maybe and see. So if I run this job, I'm expecting, so since I have 2 items here, 2 in this and 2 in the database table, I'm expecting to have like 6 items in the target table. So normally it should pass. Yeah, which means that this composite reader read data from these 3 data sources and yes. Yeah, I think it's restartable because it delegates to, let me show you very quickly the implementation we can see. Since it delegates to other item stream readers, so we save the execution context of the current delegate. So every time we use, like for example, we are in the second reader and we save the progress there. So when we restart, we know that the last time we were on the second reader at that position, and we can restart from where it left off. Here is the opening. Good question. Thank you. So yeah, this is, I think, a nice addition because it helps like in reducing the number of steps if we have a lot of data sources to read from. Now another cool feature I think is the ability to run steps concurrently, which was not possible until now. So this is based on a new implementation of item reader and item writer for a blocking queue, Java util concurrent blocking queue. For the previous, yeah, sure.
So here your example was one from a file, one from a table. Say I have a requirement like I have 2 different tables which have similar type of data. So today I use 2 separate jobs to read them from 2 different tables. So would there be an advantage using a composite item reader so that I use one job with different fragments of different item readers to read from 2 different tables?
Yeah.
Would that bring in any kind of advantage?
Yeah, so the question is, if I have 2 different tables and today we are using 2 different jobs, can I use the composite reader to read with the same job, right? And the answer is yes, if you have the same target type. Like for example, if here you can have the same target type here, person, from these 2 different tables, you can use the same composite reader, you see?
Would there be any kind of like performance improvement, or is it just a different pattern?
It's the performance is, I think it should improve the performance because instead of having 2 steps, we will have a single step. So and then a sequential read from the first table and then the second table.
Like the question is like, say the first job generally takes 10 minutes to load. Second job also takes approximately 10 minutes to load. Now that I'm using a composite item reader, does it still take like whole 20 minutes, or would I see like the overall execution time?
Yeah, it depends on the speed of the reader of these 2. Because 10 minutes the overall job or only the reading part? The overall job? Yeah, so it depends. I don't know actually. But it's a sequential read, and I think reading data is not the most slow part of the job. Every time I think getting data out of disk, I mean bytes out of disk, it's a very fast operation. So you don't, I think we don't have to optimize reading or writing. The optimization should go in the processing, which is usually the bottleneck.
These beans are separate, completely separate. So even if they are reading from similar table, why would there be any advantage at all?
If it's a similar table?
Yeah, if it's reading from two different tables.
Mm-hmm.
They will be read using separate JDBC drivers, separate JDBC calls.
No, this is a sequential one, yeah. It will be a different, yeah. So you will have like a first JDBC cursor on the first table, and then you will move to the next reader, which will open its own connection, do its stuff, and then the third one, and so on. It's sequential, yeah. It's sequential, yeah. So here is it's sequential reads. And that's what I'm saying. If you are reading in parallel, maybe you are reading from different disks or something, but if you are reading from the same disk or the same table or something, I see no advantage of doing that, because sequential reads are very fast, so you don't have to optimize that part, I think. But of course, we need benchmarks for that. Okay, any other questions on this composite reader?
So we have different partitions.
Mm-hmm.
And these are concurrently running separately, maybe in a Kubernetes cluster with these. And when the process, one of them dies, and then it is coming up, being restarted, where is that state that in that partition it already processed 88 of them, and it has to resume from 89 onwards? Is that being stored in the database?
Yes, I think that was the question as well. So is this composite item reader restartable? And the answer is yes, because in the implementation, every time Spring Batch instructs a reader to update the status here, the current delegate updates its execution context. So every time the framework does an update of the metadata, the current reader, which is the first, the second, or whatever, it will update its own status. Like in your example, it's the 88th record. So if the process dies, in the database you will have number of records 88. When you restart here in the open, the delegate will open with 88 processed records. It will position itself on the 89th item.
And Spring Batch is keeping track.
Exactly, yeah. So
within the process, it's only one at a time, your job?
It depends on the chunk size. So if you put chunk size 1, it will be 1 at a time. If you put 10, it will read 10 items.
10 taken up.
10.
So that atomicity, the restart will be at 10.
Yeah, at chunk. The transaction is...
Not from 89.
Yeah, in this case, yes. Okay. If the chunk size is 10. That's the chunk-oriented processing model of Spring Batch. A unit of work is a chunk, so it's all or nothing. So if the chunk size is 10 and I fail at 5, next time I will take the entire 10 items. Mm-hmm. Okay. So, concurrent steps with blocking queues. This is, as I said, a new architecture style. It's called a stage event-driven architecture. This is like, this is a concept that was coined in 2000, I think. It was not for data pipelines, but the idea is to apply the same ideas to data processing. And the idea is that today, if you run 2 steps in Spring Batch, so this is not the case, I will remove this one. If you have 2 steps today, sequential steps, step 1 and then step 2. Step 2 will start only if step 1 is done, like it did all the processing, read, process, write, the entire data set, and then step 2 will start processing. So the idea is that what if we can make step 2 start processing data as soon as step 1 writes the first chunk or the first item? And here is the idea. If we put like a queue in between, And we make these two steps concurrent. So as soon as step 1 will write something in this queue, step 2 can start consuming items from this queue and producing its results. So in this example, like we have these items here, first transformation, and then the second step does the second transformation and writes into a database. So this is the idea. It improves the concurrency. So you don't have to wait for the entire dataset to be processed and written for step 2 to start. And you can imagine like you have multiple stages and you have these queues in between, and all the steps are running concurrently. And of course, you don't have to wait. Like if you have 1 million lines here and the chunk size is 1,000, for example, you will have like for the first 1,000 items that were transformed by step 1, they can already be consumed by step 2. You don't have to wait for the 1 million to be written somewhere and then read by step 2. And of course, this is a huge improvement because you are faster and you are more, you have more throughput, I think, at the overall job level. And of course, we can imagine that if we have several transformations, we can parallelize steps and do several transformations in parallel. All these steps can take items from the same queue, and we can have like improved, again, throughput, and we can do a lot of things way faster than in a sequential setup. This is a very powerful architecture style, I think, and it's also suitable for data processing. As I said, the first idea came, it was for web requests, but the same idea applies here. And now it's possible, and you can do it with the new reader and writer implementations. So for example, this step 1 will have like a writer for a blocking queue, and this step 2 will have a reader from a blocking queue. And of course, the question here is, how can we know that there are no more items here in the queue and there is a timeout? Like for example, step 2 and step 3, they are reading from the queue, and if for a given amount of time there are no items, we consider that there is no items to process. The choice of blocking queue is interesting because imagine we have a fast reader but slow writers. Like having a blocking queue here allows to have like some back pressure that you can control how many items should be read and written in this queue, so you can like have a control on the pressure on these steps or on the reader itself.
But the back pressure will not apply on step 1, will it? Your RAM memory will start growing. Is that true?
Yeah, it's a blocking queue, so you cannot put items there if it's full. So the reader will wait. It will say, okay, I have some slow writers. They are picking items very slowly, so I cannot put like more than 4 items here in this example. So it will be blocked. That's the way. That's why it's a blocking queue and not a simple queue. It's exactly, yeah. It's you specify size. It's like the chunk size here, like it's a buffer size or something. It's the size of the queue. Very interesting concept.
Do you have an example for that?
Yes, I don't think it's in the. I didn't prepare one, but let's see. I don't know if we have a functional test. I hope so. Maybe in the samples, new. Okay. No, I only have unit tests, but I can create one if you are interested. I can create one. And
Since this is again between steps, so they're actually using execution concept here, or?
Oh no, the blocking queue is something that you as a batch user configure. So you say, okay, I have these 2 steps, you define your steps, and you define the blocking queue with the size, and then you connect them with the, like, you say the writer of step 1 will write to that queue, the reader of step 2 will read from that queue, and you start your queue, your steps, and they will like read and write from the queue. No. There is nothing shared between these steps. Maybe we don't need that at all. I mean, it's just a staging area of items. Okay, another nice addition is the functional adapters for batch artifacts. So this is like a feature request, like people have
Sorry, I'm still a little confused.
Okay.
Java 1.5 introduced blocking queue. So why did you say it was introduced? This style of processing was introduced in 2018.
No. I said the concept was coined in 2001. Here is the paper. So this architecture style was SIDA style, was coined by these guys from Berkeley, and they show how they can like use queues between different stages of processing. And here is the interesting part. So you see, you have these guys, and you have events coming in these different queues, and they are like showing how this asynchronous I/O for a HTTP server can be more performant than a classic server. And the same idea applies here if we replace events by items. That's the idea. So yeah, it's a very interesting.
We could have used it even before.
Yeah. But we have to have like a data structure that is similar to a blocking queue, because as I said, you need a way to block readers if writers are slow, and you need a way to block writers if readers are very fast. You see, so if we had this data structure, we could have implemented this pattern since Spring Batch 1, I think. Yeah. That's the paper that inspired this style of processing. Okay, I was here. So yeah, functional adapters for batch artifacts. So this is, it was requested by many users. Users have like these functional interfaces from Java 8, supplier, consumer, predicate, and so on. And they say, we have these suppliers for many data sets, and can we use them in Spring Batch? And of course they can, but they have to write some glue code. And these adapters like were added in 5.2 to allow these people to reuse existing suppliers, consumers, and so on as items, as batch artifacts in a Spring Batch job. So yeah, so they don't have to write this glue code. So with supplier item reader, if you have a supplier, you can use it as a data source for a step in a Spring Batch job. I think that's all in terms of features or most impactful features. We have a lot of other things in this release. I'm not going to explain all of them, but yeah, it's a huge minor release. And by the way, it's the last one for 5, the 5th generation. And I will talk about the support timeline by the end of my talk. But if you want to check the release notes and what's new, so you can go to these links. Okay, now let's talk about the next major version, and this is like an opportunity for us to improve things that we cannot improve in a minor release, meaning if we cannot change an API or introduce a breaking change or something. This is an opportunity for us to do it. And I think Spring Batch 6 will be like the most, it will not be the most disruptive major release, but it will be the most courageous release. We will change a lot of things. We will introduce a lot of new things. So let's talk about these. I just want to mention we are working on these features, but it's not a commitment. We will try to ship them all. If not, they will come in minor releases. Okay, the first one is I think the most important one. It's a new implementation of the chunk-oriented processing model. So why we are doing this? Simply because the current implementation is a bit hard to think about and hard to maintain. So it's entangled. There are a lot of parts of the code that are not modern, buggy, difficult to test, difficult to reason about. And well, yeah, we decided that we have to change the implementation to make sure that it's easier to understand, and it's of course for a long-term maintainability. We had to make this decision. We have a prototype that we released. Maybe I should add a link to the prototype, which is working, tested. It performs even better than the current implementation, and people gave us a lot of great feedback about it. And I think in V6 it will be introduced as a final implementation. I think it was released in 5.1 2 years ago, and it's in beta, and now it will be GA in V6. I'm sure there is no functional changes. There is one small change maybe in the API that I will show in another context. But our goal is that you take your Spring Batch 5 application, you change the implementation, you change the version, and you don't have any side effect on the results. So that's the goal. But if we have to change something, because yeah, we are also doing an API change, we will deprecate things and then remove them in V6. Okay, another big theme is a new concurrency model. The concurrency model in Spring Batch 5 and before that version was a bit problematic by design. The main issue in the current design is that when you have a tasklet, when you have a step, and you want to make it concurrent, you just run several threads and they execute the same step. So these concurrent threads will have access to the same instance. And of course, when you have concurrent threads like this, you have to make sure that all the code in this tasklet is thread safe. So imagine your item reader is being used by different threads. So you are reading data from a file. You know that many threads will read from the same file, but you don't know which item is taken by which thread. So sometimes you have to synchronize the access to the read operation. Also, you have to synchronize the access to the write operation and so on. So if you have an item processor as well, it should be thread safe. It's a lot of, so you as a batch developer, normally it should be transparent for you. You shouldn't be concerned about your item reader being in a concurrent environment or not. So you don't have to think about this. But with the current model, you have to do that. So if you turn your sequential step into a concurrent step, you have to synchronize your reader and writer. So this is an extra effort for the developer that in the first place should have been transparent. So as a developer, I don't care if like for example, in the Java Streams API, so I can use a sequential stream, and I can also do parallel stream, and I don't care if my functional interfaces are thread safe or not. So this is a good example that if it's sequential or parallel, as a developer, I don't care how things are managed behind the scene. This is not the case with this model, so we are trying to fix that. Another problem with this model is that it's based on locking. So we have a lot of different levels of locking. So you have a lock at the step level, so that single thread uses the step at a time. And then you have a lock, it's a semaphore, I think, at the tasklet level, and then another lock at the chunk level. So there are three differences of locking, and they are like hurting the performance, and it's difficult to even think about as a maintainer. So we have to find a lock-free concurrency model. That's another major pain point with the current implementation. We have also throttling issues. So when you specify a throttle limit, it's not respected due to this locking algorithm and so on. So yeah, that's another aspect. The third one is the transactionality of the processing as well. So imagine each of these threads has its own transaction, and then you have to make sure that these transactions are isolated from each other. There is an optimistic locking strategy at the job repository level. So there is a version field that is incremented and read by these threads. So yeah, it's a headache. So yeah, it's time, I think, to re-implement or introduce a new concurrency model. So yeah, the goal is to fix these throttling issues, have a lock-free model, and maybe base it on a producer-consumer implementation, which is easier to think about and to implement. So we have two ideas here. The first one is an item-based concurrency, and it's like this. So we can imagine an item reader that reads the items, put them in a queue, and then we have different processors reading from the queue, doing the transformation, writing it in another queue. So this is maybe the writing queue, and the item writer simply takes items from the writing queue and writes them where they need to be. This is way simpler to think about. It's the producer-consumer pattern. As I said, the reading and writing operations are typically very fast. So there is no need to try to parallelize these things or optimize them. The processing phase is the one that should be parallelized. So imagine here the item processor is doing a REST call or doing a heavy transformation or enriching items and so on. This is where the most of the processing of the step happens in the item processor. Reading and writing is typically fast. So this is a concurrent model at the item level. So we read an item, we put it in a queue, we take an item from the queue, we process it, we put it here, and so on. So we work at the item level. What we can imagine also is the same idea, but at the chunk level. Meaning that, here is the setup, meaning that the item reader can read items, put them in a queue, and then we have this new like chunk item writer. And the idea is that it will take a chunk of items, put them in a chunk request object like this, and put them in a queue. And here we will have like a chunk processor. It's not an item processor, it's a chunk processor. It will take the chunk request and process the item, the chunk. So basically it will unwrap this chunk request, take the items, and do the processing and writing. So the chunk processor is a composition of an item processor and chunk writer, you see? So it's an upper level concept. So this is the same idea as the remote chunking for those who are familiar with Spring Batch. So basically we read some items, we create a chunk, and we send it to a queue, and then another remote step can take this chunk of items, do the processing, and maybe send a reply back or update the database. The same idea applies to the local JVM, and here it's a task executor. So it's a queue of a task executor instead of being a queue like a RabbitMQ queue or something, or a physical queue, I mean a remote one. Yeah.
Previous slide on the item-based concurrency.
Mm-hmm.
So this was like a chunk-based step, assuming that the chunk size is 1,000.
Mm-hmm.
So even in current Spring Batch version, right, so we look at it as even if the chunk size is 1,000, actually the commit happens, that is where the entire 1,000 items goes to the item, right? But between reader and processor is actually one item going
At the time, yeah. So the question is,
queue actually the threading comes in the picture. How does it actually process multiple items in with multiple item processor?
Oh, okay. So I think I misunderstood the first version of the question. Yeah. So you mean the chunk size is 1,000 is for the entire thing or for the queue?
For the entire step, right? So it's a chunk-based step.
Okay, it's a chunk-based step. Okay, the chunk size is 1,000. Mm-hmm.
Generally, if you read 1,000 items, but only one item goes to one item processor at a time. It's not like 1,000 items goes to item processor at the same time.
No, yeah.
It keeps accumulating, and once it reaches the chunk size, that's when item writer moves to those actual writing. So between reader and processor, it's always one item at a time.
Exactly. Yeah. So sorry. The model you talked about is the previous one. So you take 1,000. So each thread will have 1,000 items. This is a different model. This is you have 1,000 items. These 1,000 items are processed by different threads. You see? The other one is 1,000 items for one thread, another 1,000 items for another thread. So each 1,000 items are processed by exactly the same thread. Here, it's different. We take 1,000 items, and those 1,000 items are processed by different threads. Each thread will process one item. Exactly. This is it's completely a new model. Mm-hmm. Yeah. Any other questions about this one? This is tricky to implement. It's easier. The chunk-based one is easier. It's ready actually, but this one is tricky. Because you have two queues in between, and you have to make sure that only the chunk size is processed at the same time. So these two queues should be like well-sized based on the chunk size that is specified by the user, 1,000 in your case. I think this is easier to think about than the other version here. Because now, for example, you have your reader. It doesn't have to be synchronized. Imagine you have a file. You just read from the file, put items in a queue. You don't have to think about your item reader being called by different threads and make it thread safe and so on. So as a batch developer, I write and I configure an item reader from a file, and I don't care that my item reader is being called by different threads or not. I know that it will be called by a single thread. My items will be processed in parallel, and then the writer as well. So it doesn't have to be thread safe. Spring Batch will guarantee that it's a single thread will call the reader and the writer. Of course, the processing is a different story. You have to think about this. You're not going to create different instances of the same item processor. Maybe you can do that, of course. But if you do like a single item processor and it's like a pure, from a functional point of view, it's a pure item processor. It does the transformation without any side effect. It doesn't have state and so on. You can use it in a thread-safe way. Okay, so this is the item-based concurrency and the chunk-based concurrency. This one is easily, scalable, because you just have to increase the queue size and the thread pool size. And if on a single JVM, it's not sufficient, you can go with a real queue. You just change this chunk task executor item writer with the current, it's called chunk message channel item writer, which sends these chunk requests to a physical queue, RabbitMQ or something. And you can horizontally scale your job, because these chunk processors will be on different machines. Now they are on the same JVM. So it's local chunking if you want. And you can go remote chunking if this is not enough on a single machine. So it's easy to switch between a local chunking model to a remotely chunked model. Just change this implementation here. Okay, so I'm looking forward to deliver these features and see how people are going to use them and the performance improvement. All of these are new concurrency different concurrency styles, and I think they are easier to. I'm sure it will be easier for us project maintainers to maintain the implementations. Okay, another interesting feature coming also in V6 is remote step support. So this is a new step implementation that will allow someone to run a step remotely on a different machine. And the idea is, like, for example, if you have your job and you know that one of the steps will grab a lot of data from a different data center and so on. So the idea is that instead of grabbing data from another data center, just move the step itself, the processing part, near the data there on the other data center, and run the step remotely. So the job here will run step 1, and then it will wait for step 2 to finish, which is running on another machine, and then it will proceed to step 3. And this implementation will be available in Spring Batch 6, so you don't have to. You can do that today with Spring Batch 5.2, but you have to implement this, and the goal is to make it available in the framework. Yeah, this is also interesting if you have a lot of steps and you can parallelize them on different machines. So the job acts like a manager. It will run these steps remotely and then wait for every step to finish and proceed to the final step, maybe here. And of course, since it's a distributed setup, we have to define a timeout. So if step 2 takes too long to reply or to finish, we can consider it as failed, and then we fail the job or continue, or that depends on the use case. So this is, I think, also another way of scaling Spring Batch jobs that's coming in Spring Batch 6. Okay, another theme we are working on is the integration with Spring Boot. So we have a lot of users that are not Spring Boot users. They are only Spring Batch users. But also we have a lot of users that are Spring Boot users. And the idea of this next major version is to make sure that the integration with Spring Boot is smooth. We have a couple of issues today, maybe because the default batch configuration is not so sensible. We will revisit every issue that is currently on the backlog. We will try to make the default batch configuration like not based on a data source, on an implementation detail of the job repository, because today it's based on a data source. So if you don't have a data source, it's an issue. Like when you use the MongoDB job repository, you don't use data sources. And if you do that with Spring Boot, currently there is an issue. It's looking for a data source. Yeah. So that was inherited from early versions of Spring Batch. And I think with Spring Batch 6 and Spring Boot 4, we will improve that. And also there are some differences in behavior between a plain Spring Batch application and a Spring Batch based on Spring Boot application. Like, for example, the incrementer behavior is different. The job parameters incrementer is different. When you have a Spring Boot app, it calls automatically the incrementer, while when you have a Spring Batch app, you have to call the incrementer yourself. So these kind of different behaviors are sometimes confusing, and the idea is that in the next major versions of these two projects is to align the behavior. Also improving the testing. If you are familiar with Spring Boot, there is this concept of test slice. So you only load a slice of your application, and today there is no batch slice. And the idea is to add this kind of slice, so you only load the batch infrastructure in your integration test. You don't have to load the web layer and the persistent layer and so on. That's maybe a good improvement to add in Spring Boot 4. Also, there are some non-functional changes. Of course, we will have a major release, so we are going to upgrade to the major upstream dependencies like Spring Framework 7, Spring integration, and so on, Spring data. Also, we are going to move the nullability checks to JSpecify. So currently we are using the Spring Framework annotations, and Spring Framework decided to go to JSpecify, so we are following the same idea for consistency, and I think this is an effort for the entire portfolio. And of course, the major release, we are going to clean up, remove all deprecated APIs, clean up the API, everything that is designed to be removed. It will be removed in this version. And finally, we will start from the very first milestone of Spring Batch 6, deprecating everything we see removed in Spring Batch 7. I know it's a bit far maybe, but it's the right time, I think, because there are a lot of features that are like not very modern. Maybe they were introduced and they are not used anymore. And we are thinking to deprecate them early in the process of the 6th generation lifetime, so that you are ready to remove them in Spring Batch 7. We have some polls at this link. So for example, are you using XML configuration or Java annotations? Are you using the job scope? Are you using the modular configuration style, and so on? You will see there are some questions like this, and you can help us know which features should be deprecated and removed in the next major version. So I think that's all for the non-functional changes. Now maybe I should talk about the support policies and timelines. This is the most important part. So it shows all the versions, or the supported versions for now, except for the 2, which is not maintained anymore. So the idea is very simple. We did a change, we did an update to the support policy to make it clear for people between a Spring Boot version and another project that is brought by Spring Boot, by the same Spring Boot version. For example, for Spring Batch, this version 4.3 is aligned with the same lifetime of Spring Boot 2.7. So as long as Spring Boot 2.7 is maintained, this version of Spring Batch will be maintained. So for example here, it will be until mid-2029. This is the same lifetime of the Spring Boot version that brings Spring Batch 4.3, which is 2.7 here. So the same thing for 5.2, as I said, it will be the last minor release of the 5th generation. It will be brought by Spring Boot 3.5, which is not released yet. But since Spring Boot 3.5 will bring Spring Batch 5.2, so this version of Spring Batch will be supported during the same period. And for now, it's until 2032, which is quite generous, I think. So the version I showed today will be supported for another 7 years from now. So you have time to move to V6, but yeah. This is of course, this is the commercial support. The open source support is ending in mid-2026. So very simple. If you want to know the lifetime of a Spring Batch version, you just see the support policy for the boot version that brings that Spring Batch version. So if today you are using 5.1, you will see the same lifetime of the Spring Boot version that brings 5.1. I think it's 3.4, 3.3 maybe. So yeah, that's the idea. It's very simple. It's also explained in details here in these 2 links, and we update them regularly, so you can check when Spring Boot 3.5 will be out, and when also Spring Boot 4 will be out. We will be updating this chart with Spring Batch 6 here, and it will have the same lifetime as Spring Boot 4 in that case. Okay, any question about the support? I think this is very important for those who are using Spring Batch in production.
What would be the minimum Java and Spring Boot version required for Spring Batch 6?
Yeah, good question. I should add this to the slide. What is the minimum Java version required for Spring Batch 6? It will be the same version as Spring Framework 7, which is Java 17. So we are not going to raise the baseline of the Java version. So it's the same as Spring Batch 5.2. So it's Java 17. Yeah. I think that's all for the support. So thank you for your attention. Yeah.